2.5 now, yeah? Simson line. So do you remember when we did pedal triangles?
What are pedal triangles? Yes.
So it's like when you have a triangle.
They're like off the free.
Off the tree, yeah.
So
like
lazy.
altitude.
Yeah.
Yeah, because you just move around anyways. But then you go with the cyclicals.
Yeah, I think we want to include the case where you can go outside the triangle, yeah?
Okay.
So if you have a point, you can basically find perpendiculars to each of the sides, yeah?
Yeah.
Like,
Extend it.
doesn't look linear. Okay, I know why it doesn't look linear.
Because it's not cycling.
It's not cycling. There you go.
Could be a problem there.
Okay. So basically, you get a pedal triangle, yeah? Unless it's in line.
What's a pedal triangle?
Yeah.
This is my life, guys. Okay, so any point P, right?
Yeah.
You join you make the foot of the perpendiculars to the three sides of the triangle, right? And then the 3 points, if they make a triangle, it's called a pedal triangle. Okay? And if it's degenerate,
Oh, if it's collinear.
we call it degenerate if it's collinear, yeah?
Oh,
So P, and there's like ABC is a triangle, right? Is pedal triangle for P.
okay. Pedal triangle.
Pedal P is degenerate, yeah? If and only if P lies on the circumcircle of
Why do we call it degenerate?
ABC, yeah? Triangle ABC. And when it's degenerate, it's on a straight line. That line's called the Simson line. Okay?
Explain that.
What?
Could you explain that again? We just did.
I said, do you know what a pedal triangle is? Pedal.
It's a triangle.
So you get a point, right?
Yeah.
And you make 3 points using the perpendiculars to each of the three sides of the original triangle, yeah?
Oh, yeah.
Yeah. And those 3 points are usually, they can make a triangle, yeah? So that triangle is called the pedal triangle. Okay? And then we're saying, we say the triangle is degenerate if it's not actually a triangle, it's actually just they're all on the same line, right? So the Simpson's theorem or Simpson's line is saying that it's on a straight line if and only if P is on the circumcircle. Okay? So basically, one direction you were just trying to prove, right? So when you have a circle, could make it here.
Wait, does it not work if you try to reverse reconstruct?
No. It's just easier just to do it.
Yeah, okay.
Wait, is that a pedal triangle?
Hmm?
Isn't the question you're like?
There is no pedal triangle.
Pedal
It's
line.
degenerate.
Then pedal line.
Oh.
Well,
Simpson line.
Why, it's just Simpson Lines, just a pedal triangle. Degenerate pedal.
Yeah,
Yeah.
Simpson
So
line.
you could call the degenerate pedal triangle.
Yeah.
Simpson's degenerate pedal triangle. I don't know if he would feel more on it or less on it. It's like,
So the triangle is basically super flat, and that's.
It's
Yeah,
like,
special case of this.
Yeah.
is
I think it'd be more annoying.
This is the special case because there's only one of these.
It'd be more annoying if you called the Simpsons triangles. Because then every time they say it, they have to go, well, it's actually a degenerate. It's like, what? Okay, so pedal triangle degenerates into a Simpson line if the P is on the circle. Okay, so someone want to help me with the angles today? So basically, if we can show that this angle is equal to this angle, right?
What? Come on.
Yeah.
No, you don't need two variables. Come on.
If you can show these two angles are equal, then it lies on a straight line, yeah?
Yeah.
So there's some obvious chases you can do.
Wait, which term is it
The dot and the open dot.
equal?
If
No,
those,
but you have to prove that it's a straight line.
yeah, so if those two angles are equal,
We're using the vertically opposite converse proof.
yeah.
Oh, I get it now.
So I guess this is some obvious.
Oh, that's actually okay.
Is that obvious?
Oh,
Yes.
we can't.
No,
Oh,
we're proving.
We can't. We're trying to prove it, so we can't.
No, it
The
is.
dot on
It
the
is.
left.
It is.
Yeah, but no, the dot on the left.
Yeah, that's why it's open.
That's an open
Oh, it's an
circle.
open circle. Oh.
Sure.
Yeah.
And then you go that one. You get
90 minus.
Yeah.
This is basic implication method.
Maybe they should contribute.
Yes.
I think we should
Because
do it like
we do
a.
not.
we should do a
This is
congruent,
trivial.
a congruent triangle.
Why?
That's equal to
Double inversion.
Right. You want
So
That's
so
also equal to that.
so
go quarterback.
That's also an open circle.
Double inversion.
Oh, I got it. Yeah.
yeah.
Triple.
Alright, yeah, so this angle here, right,
Yeah.
is 180 minus this angle, yeah?
Yes.
Because it's this cyclic quad, yeah?
That's quad.
Yes.
And so is this angle,
Oh, okay, sure.
right?
So,
Oh,
thus,
is that
y angle.
I mean, that's
Oh,
so
that's
that's
true.
always a delay.
Yeah.
So it's
Wait,
not-
so we solved it already?
Yeah, we did.
Oh,
We
yeah.
missed the whole solution.
No, I got it.
He got the whole
Because
thing.
since those two are cyclic, then
The two are the same, so like.
Yeah, so therefore
They
the
should-
So that uses all three cyclic quads, yeah?
Yes.
Or four.
I did another
Or
one.
Wait,
four.
Three.
Four
Wait.
cyclic quads.
There's like
Wait, so
Oh,
we use angle
it
spacing
doesn't
because
use
So
all
it's
of them.
1, 2,
Oh, we use all four.
3, and then the actual
Oh, we
original
didn't even
one.
need the last one.
Oh, you guys didn't use the
Yeah,
last
we
one?
didn't use the fourth. We didn't use the second biggest one.
But how do you know that's
Oh.
equal to that?
You didn't use the original circle.
We use the original.
No, we used the original. We just never
Yeah.
used the second biggest
we
one.
didn't use the other one.
AP. Sorry, the no AP.
Yeah.
It's the one that you just used.
Yeah, the one that you made.
The one that like the top perpendicular.
Yeah.
P.
We didn't use
Oh.
this one.
Yeah.
Oh, okay. You can avoid that with just
Yeah.
some.
Like this is
Yeah,
90
it
minus.
doesn't really matter though. Like
dot.
if you get it, then it's
90
fine.
minus dot, 90 plus dot,
How
and
do you
90
think
minus
that's
dot,
that's
and
a
then
back dot?
Oh.
Because those four.
Oh,
this is cyclic and then.
Okay,
Wait, how
cool.
do
Alright.
This is cyclic?
So we proved one direction, right?
Yes.
So if it lies on the circumcircle, then it's degenerate. Yeah. Got that?
Yeah,
That
so
was
wait,
it. If it's
wait, how do
degenerate.
the initial two
Oh,
open
wow.
circles
It's
encroach?
interesting.
Oh, okay. Because this
Yeah.
angle is equal to that angle, right? They have a common part in the middle. Yeah.
Oh no, I mean like
What's
the
the-
initial two
Yeah.
white dots.
Those two are equal.
Which arc is
And
that?
considering
Oh,
you
on
find
this
it out
arc.
in your solution,
Oh,
you
the arc doesn't have
it's
to
twice as-
actually be
it's
on the
two less
circle.
possible.
There's on another circle because it's 90-90, right? This circle.
Yeah, that's a cyclical.
Oh, okay, that makes sense.
Yeah.
So you just didn't draw the circle in.
No.
And same for the other two the black dots.
Yeah. So we're good, and if these two angles are equal, that means the open has to be equal to the closed because that's the common part in the middle. Okay. So the converse has a slight. So you guys do the converse.
Yeah.
So the converse has a slight nuance to it. So it almost basically works directly backwards. Okay. So you already know that closed circle equals open circle. That's what you assume now, right?
Yep.
and then you want to show that basically, yeah. Then I guess basically you want to show that. So now this is a double line, I guess. The double line is equal to the single line. Yeah. Is that right? So the converse basically would look like, so instead of assuming it's on the circle and having those two lines be equal, right?
Yeah.
You don't know it's on the circle, so those two lines might not be equal. But then you assume that these two angles are equal. Yeah? Right? Does that make sense?
Yeah.
And if you assume those two angles are equal, then the double line has to be equal to the single line, right?
Oh yes.
Yeah? Okay. It's not a complete proof, I don't think.
I mean, you can chase your way to
It's basically a complete proof.
Yeah, it is a complete.
So the main problem lies in the. So there's a little bit of a diagram dependency, like because P.
Oh,
Is on the circle.
directed angles.
Yeah, so
Diagram
because
dependency.
so P lies inside this angle, right?
This is anti-clockwise.
Yeah.
I do.
So if P actually lied here, right?
Johnny would.
So if P lies behind, see, because the point is that this angle, it's like, so let's call this, what's this called? What should we call this? If we call this A1, right? And this B1 and this is C1, yeah? Then, like, this angle is kind of like A1PC, right? Like, for that to be true, basically P has to be on this side of, let's call that A, B, C, yeah? Yeah, like the biggest angle you make is with A1, P, and C, right? If you put the P like somewhere else, then this C might be the bigger one, right? This C1 might be on the outside of C. Does that make sense? So basically, if P is not inside this angle here, made by B, right? Then A1 might not be the furthest most point on the outside. It might be A now. Yeah? If it was here, then like A would be bigger. And then C would be the outer point. Does that make sense?
No.
Okay.
Like B would be like right next to A, right next to P.
Yeah, let's try and draw something. Let me use blue. Yeah, let me draw a P here, yeah?
And then the perpendicular, yeah.
Because
B.
that's B, right?
Why is there a top?
And then
Diagram dependency.
Oh god. Yeah. I hate dependency. Just use directed angles. Something like that. Does it work? Like, you just
Sometimes
always
it's
do it
work.
counterclockwise.
Yeah, sometimes like in
Yeah.
this case.
You should do this.
So then you have to drag a massive line down to DC as well.
yeah,
no,
I mean
I
the
guess-
point is like, well, now if P is here, right?
Yeah, it can't be.
There's the widest angle is made by 2 feet of perpendiculars, right?
Yeah.
Whereas originally this was made by 1 feet and something on the triangle, yeah? You see what I'm saying? So that changes the way the angles add together. Does that make sense?
I guess
how
in
is
this,
that collinear?
in this case, it's not going to be collinear, and it's also
Yeah,
not going to be.
So basically, all you have to do to make the proof work is to make some argument that eliminates the case where the P is in this sort of X triangle, area and inside, right?
It won't be on the circle.
Huh?
It won't be on the circle.
Yeah, exactly. They won't be on the circle anyway, right? And that's why, like, so the proof doesn't really have to cover those cases, but like, so basically, you need an argument to say why P is not inside the triangle, for example, right? And why it's not like outside the triangle, like above a vertex. Yeah. But you can kind of see it's pretty obvious that if P is like here, it's gonna have one on each side, and the other one, like the lines that you can make over here can't intersect.
Like P would be inside A, B, and C, but then you see
Yeah.
that P was on the circle.
Yeah, I guess once you realize the issue, it becomes a much easier
A
thing to do.
non-issue.
Yeah. So it becomes just, I guess, work then. So it's like you just have to eliminate with some argument why P can't be in this weird spot over here and why it can't be inside the triangle. And then the argument works to prove the complex. Does that make sense? I think instinctively, you know that if it's inside it, it should be on 3 different sides of the triangle, right?
I feel like it has to be at least on one extended one and one inside it.
Yeah. So for it to be collinear, that's right. You probably need one of these outside intersections, right? And so once you make that point clear, it can't be inside or in these kind of angles, then the argument works. Yeah? Okay. Thanks.
Because in the top one, it has to be on 2 extended sides.
Oh, so there were some exercises here, but I thought they were pretty easy. You could probably just do them while.
B1 and C. Is equal to
So this is not a race to see who calls it out first,
Yes.
but who does call it out first
P1
will
and
win
C
the
is
race.
equal
No,
to
no, I'm kidding. It has,
I need to get some paper.
P1 and C.
Wait, give me help.
Equal to
Give me some.
C1 and C.
getting paper may lose you the race here.
Like, we're on the circle.
It may be so.
Like,
Actually, there was another comment I wanted to make. This is the most crushing comment of all.
Oh, okay, yes.
Yeah, I got you.
It's actually-
Oh, nice.
Oh yeah. He got the sword. Hey guys,
I got the assault paper.
so in the book it says this. Okay, it says
Ooh, class test version D. Let's see how
this
this
is not the quiz.
Which circle?
Bro,
Guys, listen up. Hey,
It's the
so-
first time they lost you.
Robert Simpson made several contributions to this is the most like weirdest sentence ever. Robert Simpson made several contributions to both geometry and arithmetic. For instance, it was he who discovered that if Fn is the nth term of the Fibonacci sequence, then like Fn minus 1 times Fn plus 1 minus Fn squared equals minus 1 to the nth, right?
No.
It's some Fibonacci sequence result, right? Okay, and then it says
Oh, you just bash it out with file.
the Simpson of the Simpson line was attributed to him because it seemed to be typical of his geometrical ideas.
Yeah.
However, historians have searched through his works for it in vain. Actually, it was discovered in 1797 by William Wallace.
Why is it called the Simpson line? And B, why is it discovered so late?
He's dying.
Why is it
Okay, so Simpson was known for something. So there's Fibonacci one, for example.
What's the A and B for the
and
Fibonacci?
They thought it was his theorem, Simpson's line, because it seemed like typical of what he did.
What?
But actually, this was apparently due to William Wallace.
That's unfortunate.
Yeah.
Oh, why did I find out?
So William Wallace
One
is
of
like
them.
discredited.
is Simpson's line or Simpson's theorem.
Yeah, I don't remember again now. Oh, yeah.
Okay.
Oh, okay, yeah.
Sometimes just known as the Simpson.
Just bash it out with algebra. This is-
Okay,
Could
so
have been the world, but no.
alright. Actually, maybe I'll start with an easy one. What point on the circle has CA as its Simpson line?
What's CA?
It's the side of the triangle.
Ew.
P of 1. Oh, yeah.
What point on the circle has CA as its Simpson line?
I still look at the Simson Lines stuff.
CA is it Simpson line? Oh,
Not particular from those two, I
P
guess.
equals A.
Wait, what? Which is the Simpson line?
CA as Simpson.
Wait, Michael, what's the Simpson
CA
line?
is Simpson line. Yeah,
Simpson line is the foot. Put the line joining
I
the
mean,
feet
like,
of the
what,
point.
like, what's
Yeah,
the
you
question? Like?
You just draw it.
CA is the side of the triangle. Yeah.
Oh,
If that's the Simpson line of something,
B.
what point is it?
Oh,
Oh,
BP is diameter.
Wait, isn't it?
Oh,
Oh, is it?
Yeah, I want the race. Yeah.
Is it actually?
Well, yeah, because it has to be perpendicular, right? Because AC is the Simpson line.
Oh my god.
How?
Yeah.
Really in the race.
Wait.
Damn it.
It's weird because we don't know if it's actually a race, but it seems
No,
like the
it
rules
is a race.
the rules work out as if it's a race
I don't understand.
because people are rewarded and on like discouraged. Yeah, so Haibing claimed that the point diametrically opposite B on the circle, because there's only one diameter that goes through B, right? That point has Simson Lines CA.
Also, and where A1 equals A and C1 equals C.
So then, wait, what has Simpson line?
Well,
Like A1C1.
yeah, because
I accidentally put the P.
to be on the
Wait,
triangle,
Michael
yeah,
is
yeah.
bad.
Wait, Michael, then what triangle again has
So right now,
Simpson
Yeah.
the
line
Simpson line
A1C1?
is A1, B1, and C1.
Huh?
Wait, you know
It's
for
asking
A1C1?
I
Oh, yeah,
understand.
it is
Yeah.
Spanish.
Wait, what's the Simpsons line for that? Like, if that's the Simpsons line.
So that's for this point P, yeah? So it could happen that if you moved it around, the line could move, yeah?
Yeah.
And so he's saying, what happens if the line happens to coincide with AC?
Gee, hello.
Should we call the who can make the biggest number competition with functions?
Oh,
Define
biggest
the
number. What do you mean by
biggest
biggest number with functions?
Huh?
Tree.
No, but like functions that you can define.
Yeah, I can define this. Okay. I can define the tree game.
Just do like a pen. Like,
So, you have a game with seeds.
Limit as
Like, do you know what tree is?
Lim
Uh,
10 up
Wait,
to
it's
5
actually
is
so.
or you can do like
So,
1 over
you have-
0 as x approaches 0.
Like,
it never
the
touches
tree
0,
game,
but
you have
the
like
infinite
a
is
game
very
with like
small.
different seeds.
oh, but X,
Like, for one, so the aim of the game
So,
is you try to make a forest with your trees,
Like a
with your
graph.
seeds, and then on move n, the maximum tree size you can have is n.
But
So,
isn't that the AI?
Let's say, so no, it's not. It wouldn't be the AIMO question. It's unsolvable. Anyways, like, so if you have one seed, your game dies after one move because.
You gain the what?
Oh yeah, sorry. And the rule is, you can't have you can't have like a previous like.
This is a graph,
in
right?
Each, yeah,
It's a
each
graph.
subsequent move, you can't have
You can't have
any.
a graph that's
You can't have any
subset.
subset.
Subset
which
of the
contains-
previous group.
Yeah.
So on
It's
any
like-
move, the previous moves, the graphs of the previous moves can't be a
So
subset.
yeah,
of the
if
current
you
move.
like, if you have a green dot here, and then in any subsequent one you have a green dot at all, then you'll think, then it's not allowed, right? And then, if you don't abide the rules, the whole forest dies, and then, like your job is to not die. Obviously. So one seed is one. For two seeds, so let's say first one is red, second one is like blue, and this third one is blue. So 3 is the maximum one you can have. And then tree 3 is like, it's finite, but it can't be expressed. If you know what I mean.
Like it's something that
To
you can't-
express it, you need like to express it in a proof, like to prove it with finite arithmetic. You need like 2 to the 2 to the 2 to the 2 to the 2 stacked 1,000 times. Number of symbols to prove it.
And this is me.
Something
I'm not getting any
insane.
of this. Wait, do you get any of this? I didn't get
Tree
any of this.
free.
What?
Tree thing.
Oh, I don't remember the tree thing for now.
Probably tree thing.
Right.
What are you talking
No,
about?
That will not be an AIMO question.
No, just do a fast growing hierarchy.
Yeah, okay, guys. So
Yeah, it
this is the
doesn't-
Simpson
tree
line,
3
right?
goes higher than gamma.
Yeah.
What's
Here's the
gamma?
Simpson line, yeah.
Gamma's like.
So clearly, like,
1, 2,
so say the point, the P has to be on the circle somewhere, right? We said that. Yeah.
You get into all these big things.
So,
and then gamma
We know
is
that one of the
one.
feet of the perpendiculars is already on that line, no matter what, right? And the other feet have to be on these lines, right? So, for it to be on
grows faster
that
than
line, it
gamma,
has to actually be the vertex, yeah?
Grows faster than
Right? Does that make sense?
You go
So-
faster.
So if the point P is here, right? And it has Simpson lines CA, so that's C and that's A,
gamma.
yeah?
Grows faster than
Well, one of the points is already on the line, right? And then we know the other point has to be like 9 degrees
Graham's number
on
is-
that line, right? But for it to be on this line as well, it has to be A.
Between-
Oh,
you don't
Yeah?
call it
Oh, then
Like,
it's.
and
And then this one has to be C, right?
So then it's 90. So
Yeah, so it makes a 90-degree angle here, right? So then this has to be the
How-
diameter.
Yes, you have Amiga.
Oh, okay.
That
Okay,
is.
so
Perpendicular to
first we define a function for something. Is that you have
Oh, the diameter.
hierarchy.
Oh, you don't
This
know
is
it's
the first-
perpendicular to AC.
this is
That's
the
another
first
point.
hierarchy, right? Just counting
I'll
numbers.
define. I'll define.
Yeah.
You can define.
okay.
I multiply
So
things.
Wait, could you
put
repeat that?
F0
I was listening.
and
Just not enough.
equals M.
Yeah, so basically
Yeah.
the line CA,
Yeah,
right?
yeah, that's the Simpsons line, right?
Hierarchy.
So
And
the foot of the
F1.
perpendicular
So F1.
on this side, right?
So if
Wait, on
F0, that's the
On
base
side
case.
AB,
And if you have
Yeah.
right? It has to be A
A,
because anywhere
N,
else it would make like a line
That
that's not
equals
CA,
to
right? Because we know
F.
one point is on CA already from the
of
perpendicular.
F of
Yeah.
N minus 1
Wait, so yeah,
So
so
there's one
N
perpendicular already on
iteration
CA, right?
of
yeah.
I think
You need
I think
another
you need to give
perpendicular
them examples.
To lie on
So for
CA
example,
for it to
so
be that
N
line, right?
iterations of F
But the other perpendicular has to lie on BA, yeah?
That many times.
So for it to lie on BA,
You have
it's the definition of the feet of the perpendicular, see?
Oh, yeah.
I forgot, bro. But you know how you have
It has to lie on BA and it has to lie on CA, so it has to lie on A.
Yeah.
And plus
So
three, right?
it makes a right angle at A,
How
right?
do you do the B
Yeah.
and
So then that means that must be the diameter.
Oh yeah. So you could be genius.
Okay.
So what's
Be
this?
a
What's this
genius.
problem?
Okay, another point. Does our proof
I will.
of Simpson's line require any modification?
It's like
when
or
The triangle has an
the
obtuse
BN
angle.
equals to-
Wait, which one? Wait, so ABC is an obtuse angle.
for C and F it goes B and
Okay.
No, it needs. It doesn't need any modification.
It goes just B and it goes 3 B. and-
Yeah, so I guess that's right.
must
It's either yes or no, but like,
Why is it possible?
Because look, if you obtuse angle, you just
Isn't it
push
just
C
B
up
and
a bit.
it goes 3 B and-
You just push
Yeah.
like
Yeah.
C up
Oh,
a
yeah,
bit.
B, sorry, N plus 1.
And now
Yeah,
this will be an
yeah.
obtuse angle.
And then so you
So
go.
I don't see how. It's,
yeah, and then I guess so the things you have to check. So this is a tricky question because so
Yeah.
it's pretty logical, intuitive.
it's not only the if, but it's the only if, right?
Plus
So
3C.
if it's
Oh.
obtuse, right, the same argument works in one direction, yeah.
AN plus 1 plus.
Then you have to.
well,
So
AN
basically,
plus
I'm trying
1
to tell you what you have to actually check in
plus
principle. And then on the opposite, you have to also remember how the argument was. You have to show that the angles work. And then the other direction was you have to show that P was outside the triangle and not in that angle as well, right?
Yeah, that.
And that also works when it's obtuse. Okay, and then the same argument works to get the comments. Yeah?
I don't like
So it doesn't need any modification when the angles are obtuse. Okay. Are there any points that lie on their own Simpson lines? What lines are these?
What
Yeah.
are there any points that?
Are there any points that lie on their own Simpson lines?
Oh, so that means that if other P select
Oh,
a
no,
P,
okay, you're just
that
adjusting and then you're.
A1, B1, C1 is coincide with P.
Yeah,
Either
so
A1 or C1 coincides
so
with P.
is P, A1, B1, C1 collinear? Which P is it that lie on their own Simpson lines?
Oh, so like P has to coincide with A1 or C1.
Oh wow.
Does P ever coincide with these 2 points?
P, A, B, A1, B1, C1 are collinear.
So when do P ever
P's,
lie
P's
on...
on A, P's on A.
Okay, that's one,
So
yeah?
you get P A.
P is on C, I
You
guess.
get
Why are you laughing?
It'd be unfair if you said B as well, because then you'd get 2 out of the 3.
So PB,
Well, you don't know what B is, so like.
Yeah, you can, it's B as well.
Well, yeah, I mean, like,
Is it?
there's symmetry between A, B, and C.
Yeah.
So, like, which
Oh,
which
okay,
points
yeah.
of the triangle lie on their own Simpson? Well, which point on the circumcircle lies on their own Simpson line?
Oh, well.
So A,
B and C.
B, and C. Are they the only ones?
Simpson line
think
stuff
so.
is so weird. So dumb.
So like, yeah. So like, for example, F0 N, like F0 N would just be like
and
1, 2, 3, 4, and so on, right? And then this would just be N, 2, and
Where's my phone going?
4, and right? Which are adding by N times.
F1N would be equal to F0N and
Yeah.
So what are the
Basically
Simpson
just
lines?
is N, 2, and 3, and 4, right?
No,
You're adding by N.
if N is 1, it's 1. For example, F1, 1 equal to F0, 1.
What are you doing?
Wait, if it's A.
F1 of 1. Fast growing line.
Wait, if it's A.
Yeah.
That means it's
How do you
when
talk with the
this
sixes?
is like
It's to itself,
Subtract.
basically.
1 from A,
Okay.
and then you put up N iteration.
well,
and n is 1. So one iteration of 1 is 0, 1. Which is 2.
Yeah, I guess the point is like if you have like this one, right?
1 or 2.
And it goes to P, yeah?
That means
If it has to change direction, it's already not collinear, right? So it has to,
basically
it can't
just
not
like
change
this.
direction because it always
It's gonna
ends up.
substituting n.
yeah, it's n2 and 3, correct.
And then
F2.
f2 of n would just be.
Yeah, and then it's the altitude, right? The lines.
So it's F1 n times
yeah. So then it has to be on that line.
Yeah.
Which is on it.
Oh, is
n.
it
n times 2.
Okay, so you might want to think about why there's no other points. Is it obvious? Is it only these points?
I mean, because otherwise there's
F1 is the
two of the perpendicular, like the two perpendiculars. It has to lie on the two perpendiculars, which means that like,
Yeah.
which would mean that the
Isn't
angle
three
between
tau
the two
steps?
perpendiculars is like 180,
Tau
like
And
it
then
lies on the two
and then
perpendiculars.
4 is
which
tau
means
step
some
of the
stuff
tau.
happens.
4, and basically when you get to
Yeah.
f of n, that's equal to fn of n.
It's just like up.
Oh yeah, and then so
It basically just gets up.
if it lies on the two
Yeah, you get
perpendiculars,
And then omega plus 1 is always bigger than greater.
then that would mean the two lines are parallel.
This is already way large.
Hmm.
Way
So
larger
because,
than GCC.
if say
But it is
P was
way
like
smaller.
a perpendicular to
True.
both A, B, and
But
B,
then
C.
you can keep going.
Can you draw this?
You go to like random low thing, like who gets together like
So
So let's try
Yeah.
P is perpendicular to both AB
F of
Yeah,
omega,
and
F of
BC,
omega
yeah.
plus
And then
1
lies on that line.
equals F of omega,
and lies on which line?
A on like
3, which is
yeah,
already
and lies on that
too
line.
much.
Lies on that line.
That would mean
Yeah.
that A, B, and B, C are
What's
parallel.
actually what's
A, B,
F2, 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 F3,
B, C.
just way
Because
too
of the
much.
co-interior angles.
Yeah.
Trying to get an estimate.
Yeah.
Oh yeah, it can only can't. Isn't that only on
Yeah.
what?
So it can't be like anywhere else other than like it won't be collinear other than
A1, B1, C.
Yeah, that makes sense.
A, B, and C.
Yeah, so if the 9 degrees
yeah,
were
yeah.
here, then this wouldn't be a triangle, right? It'd be parallel. Alright, that's pretty good. So let's move on.